Hello everyone, let's delve into a very detailed explanation of the provided code snippet and which implements a vectorized cost function for collaborative filtering using a TensorFlow. And this function is critical for training a recommendation system, particularly for scenarios like movie recommendation like this. And first of all, the collaboration filtering and proposed to cost function. And collaborative filtering is a technique used to predict future preferences of user based off the past interaction, move rating, or product purchases, like movies or those features. And collaborative filtering is a technique used to predict future preferences of users based on their past interactions and the interaction of other similar users. In specific code example, the focus of the building a movie recommendation system, the goal is to learn two sets of vectors. One of them and the other one. Yes, your user preference vectors is y, like that one, this, and these vectors represent the tests and preferences of each user. Each row in the matrix W corresponds to a user, and each column represents the user's affinity for a particular feature of movies. Movie feature vectors represent 2x, like this one, and this one. So these vectors describe the characteristic of each movie. Each row in the matrix X corresponds to movie, and each column represents a specific feature of that movie. The predicted rating a user might give to a movie calculated as a dot product of the user preferences vector and movies feature vectors plus a bias term. And the collaborative filtering algorithm in the set movie recommendation considers of set dimensions. And collaborating filtering cost function is this one. And the for loop implementation, start by implementing the cost function using for loops. Consider develop the cost function in two steps. First, develop the cost function with the regularization. A test case does the include. Yes. And the cost function measures how well the model prediction match the actual ratings given by users. A lower cost indicates better performance. The objective during training is to minimize this cost function. 3 improving the accuracy recommendation is this one. We have X, W, and E and R1. I'm starting here in that set, and the function takes the following parameters, some parameters. Yes, for Python this one, and the A shape, and we have a code here. It's the important part of us, X and array. The matrix of movie features, each row represents the movie and each column represents the feature that movie, and that's our X1 matrix of item features. And the number of movies and non-features is the number of features describing each movie, and W is that one. W, the matrix of user preferences. Each row represents a user and each column represents the user preferences for a corresponding movie feature. Num users is the number of users. Is this one? Yes. B1 is that. Be a vector containing a base term of each user. This term accounts for individual user tendency to rate movies higher or lower in general. And Y1 is that. Y, the matrix of actual user ratings, represent the rating given by user J to movie. Ratings are typical on a scale, for example 1 to 5 stars. If a user hasn't rated a movie, the corresponding entry W is usually 0 dimensions as a rate movie. This matrix is critical for calculating the cost on rated movies. The regularization parameter is a technique to prevent overfitting, where the model becomes to specify the training data and performs poorly on unseen data. Lambda controls the string of regularization. Yes. And we have R1, R, a binary inductor matrix in the same dimensions. This matrix is critical calculating the cost on rated movies. The regularization parameter is a technique to prevent overfitting, where the model becomes to specify the perfect data from poorly unseen data. The vectorized calculation is this. Yeah, we have a num user is 4, num movies are 5, num features is 3 is 1. This performs matrix multiplication between the movie feature matrix X and the transpose of the user preferences matrix W. The result of this multiplication, a matrix where each element represents the predict and rating movie E by user J without the bias term, is this one. The movie feature matrix X and the transpose the over preferences matrix W is that. The transpose of W is used dimensions align the matrix multiplication. And B1, the user bias factor be added. The predicted rating matrix TensorFlow's broadcasting feature automatically expand to B to the correct dimensions so that it can be added elements wise to matrix. And yes, this part, normalized dataset, and add new user indicator matrix to R, and add new user ratings where rating represent W. And yes, and the summary and importance is that all this code block, the code provides a highly efficient vectorized implementation of the collaborative filtering cost function using TensorFlow. Vectorization dramatically improves performance compared to using explicit loops, especially when dealing with a large dataset and users and movies. The use of TensorFlow allows the automatic differentiation, which is essential of training model using gradient-based optimization methods. The cost function is the cornerstone of the training process. guiding the model towards learning accurate and effective recommendation. And he provides code snippet to showcase a vectorized implementation of the Kafka's function using TensorFlow operation. Here's a breakdown of the code, and thank you for watching.